Okay, so this is for the test review. This will be question one, and this video will only cover question one of the test review. So on average, how many donors must be checked to find someone with type AB blood? Well, first off, it says only 4% of people have AB blood. So the probability that someone has AB blood is 0.04, all right? The probability they don't have it is going to be 0.96 or 1 minus that. All right, so the probability they have AB blood is 0.04. So on average, how many donors must be checked to find someone with type AB blood? So I need to determine whether I'm working a geometric, a normal, or a binomial. It doesn't mention the word normal anywhere, so this is probably not a normal. All right. So I need to sit there and go, are there a specific number of trials? And it's no, you're going to continue until you find someone. So we're continuing till we find someone. And so basically we're looking for the first one. So this indicates to me that we're working with some sort of geometric. Now, they're not telling me which one. So I look over here and I see this word on average. On average is another way of saying expect. All right, so on average is another way of saying expect. So I'm looking for the expected value of the geometric. So the expected value of the geometric has this formula, which is 1 over p, which in this case would be 1 over 0.04. When I take the calculator and I just go 1 divided by 0.04, I end up getting 25. I'm going to use the other calculator because I think it'll give a better screen, at least I hope it will. We'll try that again. 1 divided by 0.04, and we end up getting 25. All right, so this ends up being 25 for my answer. So the next one, what's the probability that there is a type AB donor among the first 5 people? So we're going to continue until we find the first. First is a keyword to tell me that I'm working with a geometric. So I know that on the calculator is going to be a geometric something, but whether it's a PDF or CDF, I still need to decide. It says among, which means it could be the first person, the second person, third person, fourth person, or fifth person. Any of those will satisfy. And since I'm circling more than one values, this makes it a geometric CDF. My probability is 0.04, and my X value is 5 because it has to be among the first 5. So if I go over here and I go second vars, geometric CDF for more than one value, I put 0.04 in, and then my X value being 5, I end up getting 0.1846, and we always want to take these to 4 decimal places. So 0.1846, that's my answer. I'm going to go ahead and highlight the answers. But this is the type of work that you need to be showing every time that you do one of these problems. All right, so what is the probability that the first donor is found on the 10th person? Once again, we have the word first. First tells me that I'm working with a geometric. And so I know that on the calculator is going to be a geo something, but it has to be specifically the 10th person. Because it's specific number, this is going to be a PDF. My probability is still that 0.04 that they gave us in the problem stem. And my X value is going to be 10. So second, vars, geometric, PDF, probability is 0.04, X value is 10. And we get 0.0277. All right, continuing on. And the reason it was a PDF and not a CDF, ooh, that's smeared badly, is because it has to be specifically the 10th person. If 85 donors are checked, how many do we expect to have type AB blood? So we have a couple things here. First off, we have a specific number of trials. We have 85 trials. Because we have a specific number of trials, this makes this a binomial. And it asks for the expected value. So we need to use the expected value formula for the binomial, which the expected value is NP, which in this case means that we're going to be working with 85, and our probability is still that same 0.04. So once again, 85 times 0.04, and we end up getting 3.4. So out of 85 donors, we would expect about 3.4 to have type AB blood. 3.4 would have type AB blood. If 85 donors are checked, once again, we're working with a specific number of trials. So since we have a specific number of trials, we are probably working with a binomial. What is the probability that exactly 3? So basically, we have a specific singular number. Because it's a singular number, this is going to make it a PDF. So this is going to be a binom PDF. Trials is 85. Our probability is 0.04, and our X value happens to be 3. So this is my trials, my probability, and my X value. Now, once again, if I were to make a number line, I go 1, 2, ... Oh, I'm on the wrong line. No, I'm not. Exactly 3 will have 0.01, 2, 3, 4, ... all the way to 85. So I'm only circling one value. Since I'm circling only one value, that makes it a PDF. So here we go. Second vars binomial PDF. Trials is 85. Our probability is 0.04 from above in the question stem. And we needed it to be we needed exactly 3 successes. So the probability we have exactly 3 successes is 0.2223. And you can round or you can truncate, it doesn't matter, but please do take it out to 4 decimal places. The 4 decimal places is really important. The next question, what is the probability that at least 3 of the 85 donors will have type AB blood? First off, we have specific number of trials. So this lets me know that we're working with a binomial. And then I see that horrible phrase, at least, which means I'm going to be needing to do 1 minus something. And since we know it's a binomial, it's 1 minus the binom. And if I were making my number line again, I'd go 0, 1, 2, 3, 4, ... all the way to 85. So I circle what I want. I want at least 3. That means 3, 4, all the way to 85 satisfies. And what doesn't satisfy is anything less. So we're going to subtract out what we don't want. And the highest number we don't want is 2. And anytime you're working with a binomial with an at least, it's going to be a CDF. So all at least are CDFs. So once again, my trials are 85. My probability is 0.04. And then my X value is 2. So a lot of people ask, why aren't we subtracting out 3? And I was like, well, we want 3. So don't take away what you want. Keep what you want, but subtract the biggest thing that you don't want. Well, I don't want 2, so I'm subtracting out 2. So here we go. We're going to do this all in one step. So we're going to go 1 minus second vars binomial CDF. Trials is 85. Our probability is 0.04. And our X value, be careful, is 2. And when we do that, we get 0.6657. All right, so our answer is 0.6657. What is the probability that there are no type AB donors in the group of 45? First off, we have a specific number of trials. We have 45. So we have 45 trials. So this makes this a binomial because we have a specific number of trials. And we want none. So let's go ahead and make our number line. So 0, 1, 2, ... all the way to 45. So what I'm interested in is 0. I have a singular value. That means it's going to be a binomial PDF. My trials is 45. My probability is the 0.04. And my X value, in this case, is 0. So second vars, binomial, PDF, trials is 45, probability is 0.04, and my X value is 0. So 0.152. I said that wrong, 0.1592. All right? And if you rounded, that's fine, but the main thing, make sure you go all the way to 4 decimal places. What's the probability there are no more than 2 donors in a group of 45? Well, again, I have a 45 trials, so this makes it a binomial, and no more than 2. So let's make our number line 0, 1, 2, 3, dot, 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 all the way to 45. We want no more than 2. So that means we want 0, 1, or 2. Well, notice I circled more than one value. And so since I circled more than one value, this makes this a binomial CDF. We have 45 trials. Our probability is 0.04. And our X value is a 2 because that's the highest value that we want. All right, so second vars, binomial, CDF, trials is 45, probability is 0.04. Of course, you can't see that now, sorry about that, 0.04, and our X value happens to be 2. So we end up with 0.7317. What is the likelihood that there are less than 5 type AB donors in a group of 120? So once again, we have a set of trials. So this is a binomial. We have a trials, 120 trials. All right? So it's a binom. Are less than 5. So we can go 0, 1, 2, 3, 4, 5, 6, dot, 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 all the way to 120. That's our number line. And circling what we want. Well, less than 5. Well, 4 is less than 5, and that's the first number. So to be less than 5, I'm going to want 0, 1, 2, 3, 4. So binomial, trials of 120, probability of 0.04. And then our X value happens to be a 4 because that's the largest value we want. Oh, and I should have said this is a binomial CDF. And I'm sorry about that. It's a binomial CDF, and it's a CDF because we have multiple values. All right, so binomial CDF. So second vars, binomial CDF. Trials in this case is 120. Probability is still 0.04, and our X value happens to be 4. And we end up with 0.4732. All right, what is the probability that there are at least 6 type AB donors in a group of 125? All right, so we have a group of 125, so we have 125 trials. So this makes this a binomial. My number line is going to be 0, 1, 2, 3, 4, 5, 6, 7, dot, 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 all the way to 125. And I say at least 6, so 6 is enough, 7 all the way to 125. So these are the values I want. What I don't want is anything less. All right? Once again, key phrase, at least. At least tells me it's a 1 minus situation, so it's a 1 minus binomial. And since I have multiple values circled, it's a binomial CDF, and I subtract out the highest value I don't want. Well, once again, our trials are 125. Our probability is still 0.04. And be careful, I want 6, so I can't subtract out 6, so the highest number that I don't want is 5, so that is my X value. One minus second vars, binomial, CDF. trials in this case was 125. Hopefully you can see that. Probability was 0.04, and my X value is 5. So 1 minus the binomial CDF, 125, 0.04, and 5. And I get 0.3840. Once again, please take this out to 4 decimal places. All right, it really helps us with the grading. So what is the expected number of AB donors in a group of 153? First off, I have a specific number of trials, which tells me this is a binomial. I see the keyword expected, so the expected value is going to be NP. I need to use that formula. Well, N is 153. My probability is still 0.04. And 153 times 0.04 equals 6.12. So I expect there to be 6.12 people, all right? What is the standard deviation for the number of donors among a group of 90? Okay, so we have a specific number of trials, which happens to be 90, so this makes it a binomial. And they ask for the standard deviation, all right? And the standard deviation for the binomial is the square root of NPQ. So we'll go over that real quickly. In this case, we know N is 90, that's the sample size. We know P is still the 0.04, but we need to talk about Q. Q just is 1 minus P. So in this case, 1 minus 0.04, which is 0.96. All right. So 90 times 0.04 times 0.96. And I need to take the square root of that number. I just raise that to the caret 0.5. And I end up getting 1.8590. Again, please take it to 4 decimal places. 1.8590. All right, so that's our first video. The second video will be a little bit shorter. Thank you.